So you might have seen, right, when you are linearly walking onto the road, right, the distance is measured in the centimeters, meters and kilometers, something like that, right? But when you're covering some part of that area, okay, that's the region, okay, some part of the region, that we are describing the area of that region, okay? For example, your bedroom, hall, right, the area is covering some of the region, right? So that we are calling the area, okay? For example, you have the 1 centimeter by 1 centimeter small square, okay? So the area inside to this square, okay, is 1 centimeter square. So area will measure the square of this distance, right? So it is not the single direction, it's as a two-dimensional one, okay? So centimeter into centimeter, centimeter square area. For example, you have the area of the 9 centimeter square. That means you have the 9 centimeter cubes like this. You may not have the same shape, but if you are totally divided into the small pieces like milli centimeter square areas, totally you'll get like 9 centimeter square area in this, okay? That means 9 times of centimeter square, okay? You can represent that way, okay? That's the area. Then, what are the areas related to the circle? We have main, right? What is the circle area? What is the circle area? Pi r square? So, is it pi r square? Yes. Okay. So, the inside area of the circle is pi r square. Outside area of the circle is what? Okay, it has infinity area, right? Outside the circle. So, all we are referring here, right? The circle area means inside areas, okay? Inside to the circle area is pi r square. That's what are the red shaded lines I'm putting, right? So, this entire region we are calling pi r square, right? So, I made to prove this circle area pi r square. I made a small video, 4 minutes video. I'll give you the link in the description box. You can go through that link, okay? So, this we are calling the circle area inside, okay? Now, what related to the circles, okay? So, one is this area, and there are the infinity chance. I said that there is infinity possibilities areas related to the circle, okay? For example, this is a circle, okay? And if there is another circle also interfering to it, okay? Then what happens? There may be common area to the two circles, okay? This is one possibility, okay? For example, instead of circle, there is a triangle is in, okay? Then it form again common region here, right? So this is the one area, right? This is also related to the circle. So that circle is cutting to the triangle. Like that, even rectangular, square and arbitrary curves and the circle area. Like that, there is the infinity possibilities of the areas related to the circle. So for your academic, there are the two cases specially studied. One is the sector area, another is the segment area, okay? So first we will take the circle. Okay, this is a circle, okay? So, this is the center of the circle and the radius of the circle is r, okay? So, what is the total area of the circle? That is pi r square, right? That's the inside area of the circle is pi r square, right? Now, for circle having how many degrees of the angle? I'm just taking in a sector to it. Sector means there is a, okay, I'm drawing from the center touching to the outer diameter and I created some region. If you want to know this area, okay, how do you do this? So this is just suspended angle with some theta, okay? So how do you know this area, okay? You know the total circle area is pi r square. I want to know only this smaller portion, whichever I shaded with white color, right? How to calculate this area? It is simple, okay? Although, let me take the circle, okay? If you divide the circle into two parts, okay? So the upper part and lower part, it form the two parts, okay? So what is the area of the upper part here? You can say simply, right? Because we just did the half of the circle, right? So we can easily tell that the upper side area is pi r square by 2, so half of the circle area. And below area is, again half of the circle area is pi r square by 2, okay? So if you made the 4 parts, let me do the 4 parts, okay? So I did with another 4 parts. So it formed the 4 parts, 1 parts, 2 parts, 3 parts and 4 parts. Then what is the each part area here, okay? So the total area is pi r square. I divide into the 4 parts. So each part will be pi r square by 4, right? So that means that the area is changing linearly with the sector angle, okay? So sector angle in this sense, right? So for the circle, if this is the center, so okay, what is the angle it is covering? Okay, it is covering like fully 360 degrees, right? What is the total angle of this circle? So this fully covering is a 360 degree angle. Okay, so 360 degree angle covering the area is pi r square, right? Okay, when you made the two offs, what is the angle? It's a 180 degrees. 180 degrees means it will become the two offs, right? So that 180 degrees angle is covering the area is pi r square by 2 off of it. But if you made it 4 parts, what happened to the each angle is 90 degrees, right? 90, 90, 90, 90 degrees. For 90 degrees area, it is pi r square by 4, okay? So what we can observe, right? It is changing the linearly with angle and the area, right? So whenever we have the linear relationship between the two things, one we know, then we can calculate for the rest of things. For example, linearly changing, okay? For example, 100 rupees, you are getting 10 pence. For 200 rupees, how many pence you will get? We just do 200 by 100 into 10, right? So that you can say that it's a 20 pence you will get, right? So similarly, when it's changed, it's not changing the price of the pens, right? Then we can calculate for the how much money you spend, how many pens you will get. So it's a linear relationship. Similarly, for 360 degree, area of the circle is pi r square. For theta degree, how much is the area? So what you do? You just do theta by 360 into pi r square, right? Okay. So when theta becomes 360 here in this, it will become like 360 by 360 into pi r square, so that it get cancelled. So the circular area will become the pi r square. So the sector area can be calculated. This is sector area is calculated theta by 360 degree into pi r square. Okay. Here theta is in degrees. Okay. Because 360 we are putting in degrees, so the theta also should be in degrees. Okay. So theta by 360 into pi r square. If you put it, you will get the sector area. So in this, whichever the angle is covered, it is a smaller means. If it's a smaller, right, compared to other angle. Okay. What is the other angle we have here? So here theta degree. What is this rest of this angle? So totally in the circle, I said, right, it is a 360 degree angle. So here theta gone means the rest of the angle will become 360 degree minus theta angle. Okay. So whenever it is a smaller things, right, smaller one we are calling like minor sector. Minor is means smaller. Okay. Minor sector. Okay. What are this larger part of this area, right? This is called the major sector. So now we come to know in a circle to calculate the two different sector areas. Okay. One is the minor sector and it's the major sector. So minor sector, any sector area, how do you calculate? It is just theta by 360 into pi r square, right? Okay. For the minor sector, how do you calculate? It is just theta by 360 into pi r square. For this major sector also, we will be calculating the same way only. But the major sector angle is 360 minus theta, right? So that major sector angle is 360 minus theta by 360 into pi r square. Okay. This way you can calculate, or the total circle area is pi r square, right? Total circle area is pi r square, and if you subtract this minor sector area, then you will get the major sector area also, right? Minus you can do the minor sector area also you can do for the major sector area. Now we will see this segment. We take a circle, okay? So this is a circle, okay? For example, there is a line, okay? I'm just drawing a line. There's a line is intersecting the circle, okay? So then what happens? Then it cut at the two locations. Let's take it cutting at the two locations at the circles, okay? There's the B and this is the A. Let's take this way, okay? So this AB you are calling the chord of the line, okay? AB you are calling the chord, okay? So chord make the, other than the diameter. Diameter is a special case of the chord, but it is just cutting at two parts any line, right? The two AB line we are calling chord of the line. So what it did to the circle, it divided the circle into the two parts. Okay, it's not the equal parts, it made the two parts. So that means it created the two regions. One is this region. Okay, I shaded this one. The another is this region, right? Here also similar. Okay, so the smaller one, right? The smaller area which we are calling the minor segments. When your line is dividing, that we are calling the segment, not the sectors. Okay, It's called the minor segment, and this we are calling major segment. Okay, so this major segment and this minor segment, right? Now, how do you calculate this minor segment area? Okay, I will show you. You'll understand clearly. Okay, let's take this is the center of the circle. Okay, now you draw two lines. This is the O, center of the circle, and this is A. So just joining the O and A. Okay, I drawn two lines. Okay, so it forms a triangle like that. OAB triangle it has formed. So it is suspended with the angle of something like that. Let's take theta angle. Okay. Okay. So now OBA, if you take not along this line, if you take along this full sector, right? So you can calculate this full sector area. Okay. For that reason, I'm just marking a point here randomly, something R. Okay, to just cover up the angle. Now I'm just drawing the area of OBRA. If you put an area of the OBA means this triangle area we will get. Okay, so that is, so this is the triangle area, right? So if you take the total area OBRA, that is current sector area. So that is, this is full area. Okay, this is the full area of the sector, right? So this is the, I'm just highlighting with yellow color. This is the full area of this sector angle. So out of this full area of the sector angle, if you just subtract this triangle area, okay, then you will get this segment area, right? So we need to subtract with the triangle area. This triangle area can write in triangle of OBA, you can write. If you subtract the triangle area, then you will get this segment area, right? Then how do you get the major segment area? Then pi r square is the total area of the circle, and if you subtract this minor segment area, we will get the major segment area. That way simply we can do it. Okay. So we do the couple of example problems so that you'll understand very easily these problems. Okay. So this is a sector having the sector angle is 30 degrees. Okay. So now here BC is the arc length and the area is covering A, B, D, C, right? So that is called the sector area. Okay. So now we keep increasing the sector angle. So area of the sector is keep increasing. Okay. Finally when it became like 360 degree of this angle, right? Then it will become the complete circle, right? So now if it is almost like 90 degrees means 1/4 of the area, and then this sector is became like 180 degree, it become half of the circle area, and it became like 3/4 is a 270 degrees almost. Then we have the 360 degree angle. If coming closer to right, it's 360 degree angle almost. That is the complete circle area, 360 degree. Okay. Okay, so this is the line where intersecting the circle at the two different locations like FG. FG we are calling the chord, and one side of this area in the circle we are calling the minor segment area, and the other side we are calling the major segment area. Okay. So this, when we keep changing the FG location, so the minor segment is becoming larger. So we can see that. Okay. Now we will see this problem. Okay. So this covers all the sector area and segment area, everything it covers. Okay. Let's see how do you solve this. So in a circle of radius 21 centimeters, okay, an angle of 60 degrees at the center. Okay. So first let me draw a circle. So what is the sector angle? It is a 60 degrees from the center, right? Let's mark the O is the center of the circle, and the radius is given 21 centimeters. So the radius of the circle is 21 centimeters, right? So this is the radius of the circle, and there is a sector, and it is a sector angle is 60 degrees, right? So the angle over here is 60 degrees. Okay. Then what do we need to find? Okay. First, the length of the arc. Okay. So this is a 60 degrees angle. So let's mark the points. Okay. This is the point A and this is the point B. So along the arc, we mark other point to just understand. Let's mark this point as R. Okay. So what is the arc? Arc is the AB along the arc, right? So A or B is the arc. Okay. Arc. Okay. So the length of the arc we need to find. First one. Okay, the arc length ARB. So what he wants again, okay? And the area of the sector formed by the arc, okay? So this arc is forming the area, okay? Then we need to find the area of, right? So let me shade with some color, like red color I'm just writing. So this area we need to find. Forming with sector, this is the area we need to find, okay? So the next one, we'll see the segment form. We'll see later of this one. First, we'll solve this first question and second question in this. Okay. One is the arc ARB we need to find. The next one we need to find the area of the sector. That is, we are calling O, A, or B. We are calling. Okay. So R is the point along the curve. Okay. Along the arc. Okay. Now, first question, okay, first we'll see. Okay, what is the perimeter of the circle? You don't remember any formulas or anything like that, okay? You can just start doing it, okay? What is the perimeter of the circle? That you know, right? It's a 2 pi r. So, okay, that how many degrees it has? For this 60 degree angle, okay, perimeter of the circle is 2 pi r, right? So 2 pi r we put it. For how much angle we need to find this perimeter, this length? For theta degree means it's a 60 degree. So for 60 degree, we need to find the perimeter or arc length. Now we cannot call the perimeter. Perimeter means circle completely we are calling the perimeter. Whichever when you are by the sector, then we are calling that is the arc length. What is the for 60 degrees arc length? What it will become? Become 60 by 360 degree into 2 pi r, right? So this is the arc length. Arc length is arc of the ARB. Okay, arc length. So 60 by 360, 60 by 360 into 2 pi r. If you substitute here, 60 by 360 into 2 into pi into r is 21 centimeters, right? If you put 21 here, so here 0, 0 get cancelled, 6, 1, and here we'll get 6, 6 here. Okay. And 2 1s here and 2 3s here. Okay. So this will become like, okay, 3 1s here, 3 7 also here. Okay. So that equal to 7 pi, right? Pi usually can be written 22 by 7, right? That's 3.14, right? So when you substitute this 7 into 22 by 7, so 7 get cancelled, you get like 22 centimeters. So the arc of the arc length is 22 centimeters here. Okay. Now the second question, what we need to find? For the second question, we need to find the area of the sector. This sector, right? Area of the sector. So how do you calculate the area of the sector? For 360 degree, so area of the circle is pi r square, right? Okay. For how many degrees you need the area? For 60 degree, what is the area you need to find? Then it's just simply 60 by 360 into pi r square. So pi into r is 21, right? So 21 square. Okay. So this is like pi by 6 into 21 into 21, right? So if we put 3 2s are 3 7. Okay. So that equal to pi can be written 22 by 7 here. 22 by 7 into here 7 into 21 by 2, right? So here 7 get cancelled. Here 2 1s, 2 11 here. So 231 centimeter square area. So area is always square, right? 231 centimeter square. Here we have the r square now. So squaring the centimeter. So centimeter square will get. That's the 231 centimeter square. Okay. Now we found the arc length is 22 centimeters and the area is of the sector is 231 centimeter square. Okay. Now let's see the third one. Okay. So area of the segment formed by the corresponding chord. Okay. Corresponding chord means, right? So from these 2 points, if you join this line, okay. Okay. Then this is called the chord. Okay. So corresponding chord area is forming means this is the area. Okay. Segment means I said this is the segment area. So the yellow highlighted area we need to find. How do you find this yellow highlighted area? For the total sector angle, that is total sector area, that is the O, A or B, that's the total sector area, minus this triangle area. If you put it, you will get this segment area, right? So the total area is 231 centimeters square here, total sector area. Now we will find this triangle area. Once you find this triangle area, then we will subtract from the total area to this triangle area. Okay. So I will make it in the next slide. I will take this picture. So let's mark the same points. Center is O. This is the point A and this is the point B. And along the point curve is point R. Okay. So now segment means now if we join this AB line, right? So if we join the AB line, so this area we are calling segment area. Okay. How do you get this segment area? The total sector area, that is OA or B, is the total sector area minus triangle area of the OAB triangle area. So subtract the triangle area, we will get the segment area. So how do you find this triangle area? Let's draw a perpendicular line from the center. Okay. So that point where it is touching to this base, right? Let's mark this point some M. Okay. Okay. So you know, right, in the circle theorems, so for the segment, if you draw perpendicular line that bisect the angle, okay, that means this total angle is 360 degree. Sorry, the total angle is 60 degree. If it's a bisecting, each angle is, this is the angle become like 30 degree, and this is a 30 degree, and this is a perpendicular line. Okay. So now for the triangle area, we need to know base into height, right? The base, let's take the AB. Okay. So triangle area, I'll put area of the triangle OAB if you put it. So that off into base is the AB is the base. The base is AB, let's take, and height is OM. Okay. If you know the AM length and OM length, then you can find the triangle area, right? So now let's see. So AB equal to, again, so it's the sum of AM and MB, right? So this is called AM and MB is the sum of, right? So both are equal, right? So in here it's bisecting, I said, the angle, right? So both are equal because this angle is 30 degree here. Okay. Both are congruent triangles. So both are same. So you can write 2 times of the AM distance. If you take the triangle OMA, okay. So we have the 90 degrees set the angle M. Okay. So how to calculate this distance? We need to know OM distance and the AM distance, right? So if you take sine 30, opposite side by hypotenuse, right? So what is the opposite side? Opposite side to the 30 degrees is AM is the opposite side. What is the hypotenuse? OA is the hypotenuse. Okay. We need to find the AM. Okay. If you go AM here, it will become like OA into sine 30, right? What is the OA? OA is the radius of the circle. That is 21 centimeters is the radius of the circle into sine 30 is 1 by 2, right? So if you divide with this, it will come like 10.5 centimeters. Okay. So the total, how much is coming? The total AB will become, so it's 2 times of the 10.5, right? That's equal to 21. So AB also 21, right? So AB is 21. Now we know the base. We need to know the height OM. Okay. How do you calculate the OM? If we take the same triangle OMA, can you write the cos 30 here? Cos 30 equal to adjacent side, that is OM by hypotenuse is OA. So here you can write the OM equal to OA into cos 30. Okay. So here OA is radius. This is the radius of the circle, right? Radius of the circle is 21. Okay. Into cos 30. Cos 30 is root 3 by 2, right? Now substitute this AB and OM values into the area of the triangle. Okay. Now triangle area, so I'm just writing here, area of the triangle OAB equal to half into, what is the base? Base is the AB I'm taking, okay. AB is the 21 basis, right? So 21 into, what is the height here? So height is OM, right? OM is 21 into root 3 by 2, right? 21 into root 3 by 2. 4, 1 into root 3 divided by this 2 into 2 is 4, right? So now this is the area of the triangle, okay? So now we have to find the segment area, okay? That means ORB, that is the total sector area minus this triangle area. Total sector area is how much? It's a 231, right? So 231 minus area of the triangle is 441 into root 3, okay? 4. So this is the area of the segment. You need not to simplify this, okay? You can keep it as it is, because this is all get the decimal numbers and decimal separations you will not to do, okay? You can just put the area of the segment is 231 minus 441 into root 3 by 4, okay? This is our final answer, okay? Suppose if we want to find the major segment, okay? This is called the minor segment or the sector formed segment. It is called sector formed segment, okay? This is the area, okay? If you want to know the major segment, right, the rest of the segment area, so this area is corresponding to this segment. So what you do, the total area of the circle is pi r square. We'll subtract pi r square minus, we'll put this total segment area. Then you get the major segment area, okay? I think that's the end of this class. I think in this class you will learn the sector, minor sector, major sector, minor segment, major segment, and areas related to both, okay? So if you have any questions, write in the comment section. If you have any problem to be solved in the exercise problem or anything, please write comments below, okay? I will explain into the separate video. Thank you.